Hi guys, so this will be the last topic for our calculus, and that is higher integrals. So just like derivatives, so integrals also have higher integrals, but not quite the same with our higher derivatives, the first derivative, second derivative, fourth derivative, and so on and so forth. For integrals, for higher integrals, so we have to integrate what is already integrated. But so for example, if you have higher integrals, you have double integrals, triple integrals, quadruple integrals, and so on and so forth. So if we have a double integral, for example, so this is our double integral, we have f of x and we have f of y, and that is dy dz. Limits, we have a to b and c to d. So if this is our double integral, so the limits a to b is from dy, and the limits c to d is for this is dx, I mean. So for double integral, so what happened is that, so the limits a to b is for dy, the limit c to d is for dx. So the integral sign and the dy, or the differential, so this will be the equivalent limits of dy, and this will be equivalent limits of dx. So if we have triple integral, so if this is our triple integral, if we have f of x, f of y, and f of z, so we have dy or dz, dy, and dx, limits from a to b, c to d, e to f. So dz limits is from a to b, CD is from dy, and e to f is for dx. So that is for higher integral. So higher integral are used by many applications engineering, especially on higher engineering mathematics, because they are used to determine the area, the volume of a solid figure. So let us try some example of double integrals and triple integrals. So for example, if we have integral of x squared y dy dx, limits from 0 to 1 for dy for y, and limits 1 to 3 for dx. So if we have higher integral, so what we are integrating, so what variable we are integrating are the variables that we will integrate. So therefore, other variables will be constant. So in this case, since we are integrating our y with y, so our x will be constant. Why? Because the limits of our x, we will not integrate x, because the integral of x is here. So therefore, what we have to do is we have to integrate y first. So if we integrate y first, the integral of y is y squared over 2. So rewrite the first integral sign, limit from 1 to 3, and then copy this x squared. And then what is the integral of y? That is y squared over 2. Limits is from 0 to 1, and we will still have dx. Next, so rule on definite integral. So what we have to do is we will substitute. So therefore, we have integral of 1 to 3 of our x squared. So therefore, y squared over 2, substitute to 1. So we have 1 squared over 2 minus z squared, 0 squared over 2, then dx. So therefore, this will be integral of 1 to 3 of x squared. So this will be 0, and 1 squared over 2 is 1/2 dx. So simplifying, this will be integral of 1/2 x squared dx. And now, we will now integrate. Again, but we will integrate with x. So this is 1, 2, 3. So if we integrate to x, so we will integrate x. So integral of 1/2 will be constant, and then integral of x squared, integral of, or this will be 1, 3, then x squared dx. So if we integrate x squared, so that is x cubed over 3. limits of x is 1, 2, 3. And we will substitute. So 1/2 as constant, and then 3 cubed over 3 minus 1 cubed over 3. And then we will simplify. So we have 1/2 and then 3 cubed, that is 27. 27 divide 3. So that is again 3 minus 1/3. So if we simplify, so if we have 1/2, 1/2 multiplied to 3 minus 1/3. So therefore, that is equivalent to 4 over 3. So the double integral of x squared y dy dx, limits of y is 0 to 1 and limits of x is 1 to 3 is 4 over 3. Another way to solve our integral on this kind, if our variables or our functions are multiplied, you can separate them individually. So what we will do, so let us get x, integral of x squared dx. What is the limit of our x? That is from 1 to 3. Then multiplied to integral of our y. So y dx, limits that is 0 to 1. So therefore, we can write this. What is the integral of x squared? So that is x cubed over 1. X cubed over 3, and limits is from 1 to 3. Multiplied to integral of y squared over 2, limit 0 to 1. And get the value. So this is 3 cubed minus 3 minus 1 cubed minus 3. Multiplied to y squared, so that is 1 squared minus 2 minus 0 squared over 2. If we simplify, this is also equivalent to 4 over 3. So this method is only applicable if our functions are multiplied to each other. So if it is not multiplied, so therefore you have to do this method. Another example, if we have integral of x sine y dy dx, limits 0 to pi over 2 and 0 to 2. So therefore, 0 to pi over 2 is limits of dy and 0 to 2 is limits of dx. So if we will write our integral, let us check. Our two variables are multiplied, so therefore we will not do the original method of integrating, but rather we will integrate x dx, limit from 0 to 2, then multiply to the integral of sine y dy, limits of y is 0 to pi over 2. If we integrate x, so this x squared over 2, limits is from 0 to 2, multiplied to integral of sine y is negative cosine y, limits is 0 to pi over 2. Then we will substitute. So we have 2 squared over 2 minus 0 squared over 2, multiplied to negative cosine pi over 2 minus negative cosine 0. So therefore, 2 squared over 2, so that is 2, and this is 0, multiplied to negative cosine pi over 2, I think that is negative 1, negative cosine pi over 2, negative cosine shift pi over 2, so yes, that is 0, then minus negative cosine 0, so we have negative cosine 0, then plus, negative. What is cosine 0? Cosine 0 is negative cosine 0, so that is negative 1. So we have negative 1. So if we simplify, so this is 2 and this is 1, so therefore this is 2. This is what, where's example number 3? This is what I told you about. So if our integral, if our values are not multiplied, but rather there is addition between them, so we cannot choose this method that we can only multiply, but rather we have to integrate them separately. So therefore, The limits of x is 0 to 1 and the limits of y is 1 to 3. So therefore, we have to integrate this with x first. So 1, integral of 1 with respect to x, so that is x. So limits is 1 to 3. Then this integral of 1 with respect to x, that is x. And integral of 4xy, so 4 and y are constant. So we have to write 4y, and integral of x is x squared over 2. And limits of x is 0 to 1, and that is dy. So integral from 1 to 3. So therefore, simplifying, so this is cancelled and this is cancelled. So therefore, this is equivalent to x plus 4 and cancel 4. So this is 2. So we have 2x squared y. Limit 0 to 1 dy. And we will substitute our limits. Integral from 1 to 3. And then our x is, no, highest value is 1. So we have 1 plus 2 times 1y. Then minus, no, that is 1 squared. So we have 0 plus 2 times 0 squared times y. Then dy. So 0 plus 0, so this is 0. So this will be integral of simplifying this. So we have 1 plus 2y dy. And we will integrate this with dy with the limits from 1 to 3. So if we integrate that, so that will be, no, so integral of 1 with respect to y, so that is y. Integral of this with respect to y, that is 2y squared over 2. Limits from 1 to 3. So therefore, if we simplify from our lower limit and upper limit, so we have 3 plus 2 times 3 squared over 2. Excuse me. Then minus, we have 1 plus 2 times 1 squared over 2. So if we simplify, so this is 3 plus 9, so we have 12. And this is 1 plus 1, so minus 2. So this is 10. So for triple integral, so it will be the same. It is a triple integral or it is a 4 integrals. So, but don't worry. So we are only dealing with 4 integrals. But as what you have noticed, guys, in this problem, we have integral of x, y, z, dz, dy, dx, limits from 0 to y, 0 to 4, and 0 to 2 for x, z, y, and x respectively. But since even though our x, y, and z are multiplied, we cannot apply the previous method just like this because the limit of our z is from 0 to y. So if the limit of if our limits are variable, so you cannot direct do the multiplication for double integrals. Yes, for higher integrals. So, but still, we will use the long method of integration. So therefore, since y, the limit of z is 0 to y, so and we are integrating z, we will only integrate z. X and y will be constant. Sorry, right? Integral 0 to 2, integral 0 to 4. Then integral of xz is constant. Xy is constant. Integral of z, that is z squared over 2. And the limit of z is 0 to y. Then we have dy and dx. So since the limit of our y, the z is from 0 to y, so we will substitute as rule in definite integral. So xy is constant, and then limit z squared y, so z squared y, so we have y squared over 2 minus 0 squared over 2. Then this we have dy dx. So this is 0. If we simplify this, so if that is 0 and if we distribute, so we have integral 0 to 2, integral 0 to 4. So therefore we have x y raised to 3 over 2. And we have dy dx. So as what you have noticed, we have x and y are now multiplied to each other. So we can now separate our integral using multiplication. So we have integral of 0 to 2. So 0 to 2 is limit of x. So we have x dx multiplied to integral of y cubed over 2 dy, limit is 0 to 4. And integrate. Integral of x is x squared over 2. Limits is from 0 to 2. Then multiply 2. Integral of y cubed over 2. 1/2 is constant. So y raised to 4 over 4. Limits 0 to 4. And then substitute our limits. So we have 2 squared over 2 minus 0 squared over 2 multiplied to our constant 1/2. Then y raised to 4. 4 raised to 4 over 4 minus 1/2. 0 minus 1/2. 0 raised to 4 over 4. So this is 0 and that is 0. So if we simplify this, so this is 2 squared over 2. So that is 2. I'm so sorry. Then 4 squared over 4. 4 cubed. 4 cubed. This is 4 cubed. So 4 cubed divide 2. So I don't know. Let us solve. 4 raised to 3 divided by 2. So that is 32. Then 32. So that is 30. 32 times 2. So that is 64. Yes. And another example. So we have integral of x dz dy dx, limits from 0 to 1, 0 to 2, 0 to 4 for x, y, and z respectively. So this is multiplied. So even though there is no variable y and there is no variable z, so you can integrate. So if we separate, we have integral of 0 to 1 for x dx multiplied to integral of dy, limits from 0 to 2, and then multiplied to integral of dz, limits 0 to 4. So we can integrate dy, and that is y. We can integrate dz, and that is z. So therefore, we can integrate. So this is x squared over 2, limits from 0 to 1. Multiplied to integral of dy is y, limits 0 to 2. Multiplied to dz, z, limits 0 to 4. And then substitute our limit. So we have 1 squared over 2 minus 0 squared over 2. Then multiplied to 2 minus 0, multiplied to 4 minus 0. So if we simplify, so this is 1/2 multiplied to 2 multiplied to 4. So cancel. So this is 4. And that is for higher integrals. Thank you guys.